Good afternoon, this is Schweitzer, and we're going to do a trig and some vectors that will help us explain, okay, how I use trig in order to find component and resultant vectors. Alright, so anytime I have two vectors that are coming in and sort of interacting with the same object, it could be something as simple as a pool ball that maybe, well, here's an actually kind of unique example. You might know if you ever play pool. You know, your pocket right here, the ball here, so the wall, and of course, if you have a pool ball, so you, let's say 8 balls there, and you shoot your pool ball, hits this ball, hits that ball, and exactly the same time as it's at the wall, your ball bounces off, and that ball stays there. So this ball is receiving let's say some amount of Newton force, X Newton force this way, and it's also receiving an X Newton force negative in the other direction, and therefore has no net force on it. The sum of the forces on that ball equal 0. It does not move. So couple things that we want to make sure we point out here about resultant vectors. First of all, in order for one vector to directly cancel another vector, it must be what I call in line, in the same line of path, whether it's up, whether it's like this. Okay. If I have two of these guys going the same direction, my resultant vector is up and up. Now again, we'll do more in the future on vectors and adding and subtracting vectors, but whenever we're adding vectors, we always want to hook a tail and a head together. You'd never want to hook two tails, two heads. This is my resultant vector that is a result of adding those two vectors together. We call these components, and this is the resultant. Okay, so they draw them together. In this case, for these two guys, the only way to hook a head and a tail together is to literally lay them right on top of each other and subtract them. So there is no vector putting these two guys together. I could, however, have something like this. If I have a 5 Newton going against, let's say, a 4 Newton force, and in this case I end up with a 1 Newton force is my resultant vector. I'm using newtons here, but you guys could use meters per second or velocity or acceleration, anything that's a vector. So in this case, we're looking to look at how I can use two vectors to create a resultant vector. And in this case, I'm going to do some simpler examples, although it's not entirely all that difficult to do anything more complicated. But if we were to have, for example, a vector of 5 newtons going to the right, and another vector, let's say 7 newtons, that is going straight up, what would be the resultant vector of these two added together? So that's the goal of this particular little video, is to do resultant vectors. Okay, now what's nice about this is acting in the X direction, this is acting in the Y direction. So we're not doing anything that requires anything other than some basic trigonometry. So you should note that if I want to add these two things together, there are two ways to do this. One is simply with a graph. If you were to have graph paper and you drew the lines to scale 5 and 7 precisely to scale, and then you take your tail of one, your head of the other one, 7, 5, this line right here would not only give you the length would be the off of a key or a proportional to the actual ending vector. The resultant vector's length would be proportional to this magnitude. And you also could get your protractor out and actually get this angle. Okay, so we'd have not only the value based on the length of this head to tail vector, but the angle could be given as well. Now, mathematically, how do we go about figuring this out? Well, if I have a triangle, in which case the y is 7 and the x component is 5, I have a right triangle. How do I figure out this value? Well, I would use the Pythagorean theorem in this case, which is a squared plus b squared equals c squared. So this would be my a component, this would be my b component, this would be my c component. So a squared is 7 times 7 is 49, plus the b component, which is 25, which is 5 squared, equals my c component squared. Now again, oh man, I don't know what the actual answer here yet is, but I do know that to get rid of this square, I got to square root both sides. So it's going to be c equaling the square root of 49 plus 25. Not a very difficult addition of 74. Now, if you want an exact answer, you could just leave that square root of 74. Or if you want a decimal version, then you would get about 8.6. C equals 8.6. And because we're dealing with, well, actually, this in here, I didn't give a unit. If it was newtons, this would be in newtons. If it was a velocity, then it would be meters per second. Alright, so I've used two sides and find the third one from a resultant vector, which is 8.6. Now, quite often I want to know an angle. Okay, so for the angle, I can use one of my trigonometric identities. I have SOHCAHTOA, which is, again, kind of reminds you, that's an A. How do we do it? Of all my identities. And you can pretty much pick whatever you want. You could do, in this case, since this is my angle I'm looking for, I could say, okay, well, let's do the opposite over the adjacent. So the tangent of the angle is equal to the opposite, which is 7 over 5. Alright, so in this case, take the inverse tangent, so the tangent inverse, it'll give you a minus 1 to the second, that's the second function of the tangent of a tangent. Of course, the tangent of a tangent just kind of wipes out the tangent, okay, and I get just the theta. But if I'm going to do this algebraically, I do it to both sides, so it would be inverse tangent of 7/5. And again, if you want an exact number, I guess you just leave it like that, but let's do get the angle here. Tangent of 7/5, about 54 degrees. Right. This guy's 54 degrees. This guy's 90. You could subtract off 180 for the third circle. All right. And that's a typical example. Okay. We could try one more example, and of course, if you want to follow along at this point, I'm going to go a little faster. You could then pause the video and try it on your own. Alright, so let's have two of these things. We got a vector going this way, which is going to be, let's say, 10, and another vector coming straight up. Okay, and we're going to say that this happens to be two vectors that line up nicely. This angle is 45 degrees. This angle right here, therefore, is 90. Okay, and we'll say that that's all I'm going to give you. Okay, so I have two vectors that are colliding at 45 degrees. I know the angle is 45. Okay, I know this angle is 10. Alright, I want to know everything else. Okay, I want to know the resultant vector. Okay, now this is going to be, well, actually, let's just, well, we can get a this case, let's back this problem up here a second. Okay. In this case, because I have two arrows that are put nicely together, like this one, and I have another arrow here. Okay. So someone might think, you know, this is going to work out nicely because I got myself a 45-degree angle here and 90 here. But whenever you're putting vectors together and you want to add them, be very careful about how you line them up. Now you'll notice here that, well, if I have a ball and I hit this thing in this direction and in this direction, the ball likely is going to go somewhere over here. But if you take this angles and not think about it, you might try to connect up a vector this way or a vector this way, and that just simply isn't logical. So if you see two vectors like this, you'd want to say, okay, well really this is a 45-degree vector and a straight up vector, and now this is my new vector, which isn't a right triangle, and we'll cover how to handle this. But in this particular video, this is getting beyond the scope of this video. So let's change up our problem. And let's say we just have an x vector at, let's say, 10, and let's say a y vector that's attacking or hitting the item at, let's say, a 4. And I want to figure out the magnitude of the resultant vector, which is this guy right here, and the angle that it takes off at, which is right there. Go ahead, pause the video, and give it a try on your own. Alright, now to solve this problem, let's just go ahead and figure out r using the Pythagorean theorem. So 4 squared plus 10 squared equals c squared. That's going to be 16 plus 100 equals the square rooted. So 100 and the square root of 116 equals 10.7. So r equals 10.7. That's this guy. And now I want to find the angle. I'm going to use the cosine of the angle equals the opposite, which is the adjacent, which is 10, over, let's say, what we just calculated, 10.7. So in this case, I would take the second cosine, and then I would go 10 divided by 10.7 equals, and my angle is 20.8 degrees. Angle equals 20.8 degrees. Alright, give it a try.